The Rocky Mountains. They stand almost 15,000 feet tall. Very few make it to the top. In fact, only 30% of those who take up the challenge make it. Others collapse, get frustrated, or just start crying. There's one man who is out there to make a difference. Kind of. This is Donald. Donald owns a bakery just to the bottom of a mountain. He guarantees any customer that comes in before their hike and purchases his Rocky Mountain Cookie Special for a small payment of $19.95 will make it to the top of the Rockies.
Disclaimer: voice disfigurement used to prevent phone call tracing through his actual voice. Yes, these things exist.
Yes, this cookie is unlike any other. Once you eat it, the chocolate chips activate a special part of your brain that gives you a superpower to climb the mountain.
We decided to put Donald's claim to the test. We randomly selected 80 of his mountain hiking customers and observed who made it to the top and who didn't. Our results showed that a grand total of 12 of the 80 customers did not make it up the mountain. We took these results to our statistician to see if Donald's cookies are the real deal. We are trying to figure out if Donald's cookies are the real deal. The way to do this is through hypothesis testing. The first step in hypothesis testing is writing down our two possible outcomes. We'll call them the null hypothesis and the alternative hypothesis. The null hypothesis is when we ignore any claim that would affect from our original result. So, in this case, at the beginning of the video, we said that 30% of people could climb the mountain without any kind of help. So, our null hypothesis claim would be that Donald's cookies do not increase someone's ability to climb the mountain. So our probability, or P, would remain at 0.3, or 30%. After establishing that, we can write our second possible outcome, or the alternative hypothesis. The alternative hypothesis is what would happen when we do take into consideration any outside sources. So in this case, we would say that Donald's cookies does increase someone's ability to climb a mountain. So our probability would be greater than 0.3 or 30%. After stating our two possible outcomes, we want to make sure all conditions are met before we start testing. Typically, you want to look out for these three. In the problem states it took a random sample, so that's good. Next, we follow the 10% rule, which is the number of people you were using in the sample. So for this problem, having 80 people, it's less than 10% of the population in general. And finally, we have our success-failure rule, which in simplified terms, you have P, which is your probability of success, times N, which in this case would be 80 people. And it would need to be greater than 10. Just like the probability of failure, which is Q, times the number of people, which is 80, must also be greater than 10. If it is so, then we can continue with testing. So what we'll do first is take the percentage of people that did not make it up the mountain with the cookie, which is 12 out of 80 people, equaling 0.15 or 15%. And now we'll subtract that by the original claim of people who made it up the mountain without the cookie. So when you subtract 1 minus 0.3, you get 0.7, which is the people succeeding at climbing the mountain without the cookie, which will be used to calculate standard deviation. For standard deviation, we multiply 0.3 times 0.7, which is your success times your failure, divided by the number of people in the sample, which is 80. After that, you will square root it to get your standard deviation to use in the equation. Now for our equation, all we have is our x minus our average mean, which is what we were given, which is 0.30. So the 0.15 minus 0.30 is then just being divided by our standard deviation, which is what you just found. And now we just found our z-score as a product of the previous equation, which is negative 2.97. All it is when we are looking at the normal distribution to show how far of that z-score with standard deviation to see the proper p-value. So when we go into the calculator, we will put in normal CDF. And we will first have negative 1,000, doesn't matter how big it is as long as it's negative, comma negative 2.97, giving us a p-value of 0.00175. What does this mean? Well, with this value that you just got, it's a chance that you would see a climber that purchased a Rocky Mountain cookie not make it to the top. That is a very, very small chance. The chance is smaller than 5%. the percentage used often in hypothesis testing to determine whether or not we should accept or reject our null hypothesis. In conclusion, we reject the null hypothesis. We reject the original claim that the baker's cookies, aka Donald, does not increase the chances of a climber reaching to the top, because by the equation we solved, we have only a 0.00175 chance of witnessing the baker's cookie fail to get someone to the top. And 0.00175 is equivalent to a 0.175% chance. And now we have one more part. In the rare occasion that we cited an error, we would always be able to have two options as to what that error could be. These are called type 1 and type 2 errors. A type 1 error is basically what could go wrong if we didn't find enough evidence to prove the claim. So that would be like if in a courtroom an innocent man was sent to prison because the equation we solved did pass the 5% mark. In this case, type 1 error would be that Donald's claim was true and we believed it to be false, and now he's losing business and is forced to shut down, which is impossible since he's rarely rich. And in type 2, it would be if we found enough evidence for a wrong claim. So if we were in a courtroom with a guilty man and the guilty man ended up going free. So in this case, if we believed his claim to be true for Donald, then now people would be buying cookies for $20 and it'd be for no reason. And he'd probably end up calling it